61 asks us to write the equation that represents the information in the equation map. So remember, this means equal here. And then we just need to remind ourselves the value of each of the tiles. So if it's shaded in, it's a positive. If it's unshaded, it's a negative. These small square tiles are 1 unit tiles because they're 1 by 1, so the area is 1 because 1 times 1 is 1. These small rectangles are 1 by x, so the area is x. So those are x tiles. Now, the bottom of the equation map, that's the negative portion. We don't want to have to deal with the negative portion, so we're going to flip and shift. So we take these tiles and we flip them up here. When we flip, get to the other side. So it was unshaded, now it's shaded. It doesn't exist down there anymore. We're going to do the same thing with the 2 unit tiles. And also over here. We have 2 negative x's down here. Well, they're really negative negatives. So we flip it up, and we see that a negative negative is actually a positive. It doesn't exist down there anymore. Okay, so let's see what we have. We have 3 x's plus 3, 2 x's plus 2. They're all shaded in, so they're all positive. We have our equals. So we end up with 3x plus 3 is equal to 2x plus 2. Problem 62 asks us to simplify the expression map and write the result. So once again, we need to refresh our memory on the value of the tiles. This tile here is x by x, so that means it's an x squared tile. These tiles are 1 unit tiles. Now, they're unshaded, so that means they would be negative. They would be on the negative side. They are 1 unit tiles. Again, 1 unit tiles. Now, this one is actually slightly longer than the x. It's a y. So it's y by 1, which is y. Now, we want to flip and shift so that we end up with all of them on the positive side. We know how to work with positives. So we're going to take this y, I'm going to flip it to the back so that now up at the top, but it's unshaded. Same with these tiles. We're going to flip them up here, flip and shift. So flip it to the other side so it's unshaded and then move it up. Flip and shift. Flip it to the other side, move it up. Okay, what do we have left? We have x squared. And how many y tiles do we have? We have 1 of them, but it's negative, so it's minus y. And then we have 4 of the negative ones, so minus 4. Therefore, our expression is x squared minus y minus 4. 63 asks us to find the sum of the polynomials represented below if this tile is x squared. So I'm just going to write x squared on all of those. Do we have any others? No, we do not. Okay. These tiles are my x's. If it's shaded, it's positive. If it's unshaded, it's negative. So unshaded is negative, so this is going to be negative x. These are 1 units. They're negative, so this one's negative 1, and this one's negative 1. This one is my x squared, but it's negative, so negative x squared. And these are all positive x's, so x, 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 x. Last but not least, we have our 1 tile down here. It's positive 1. Okay, so it asks us to find the sum of the polynomials represented. What do we need to do? We need to combine like terms. So let's see. We have 2x squared minus x minus 2. And then we have negative x squared plus 4x plus 1. Well, we can see that these two tiles here are the same shape as this one, but this one's negative. So that means that this cancels one of these out. We can confirm this by saying 2x squared minus x squared is simply x squared. And that's all we have left. We have 1x squared left. Okay? Then we say, well, we have a negative x here, and that's going to cancel one of our positive x's. So what are we left with? We're left with 3x's. Let's look down here and see if we get the same thing just by looking at our numbers. Negative x plus 4x would give us plus 3x. Same thing. Again, the tiles are just a way to represent, so we should get exactly the same answer. If not, we're not doing something correctly. Okay, and then last but not least, our unit tiles. We have 2 negatives and 1 positive, so this cancels one of these out, and we're left with one of the negatives, so minus 1. And if we look up here, we would have minus 2 plus 1, which would give us minus 1. So our simplification is x squared plus 3x minus 1. Simplify the expression. So we just combine like terms. So we have 2x and minus 7x would give me minus 5x. And then minus 6 minus 12 would give me minus 18. So we have 5x minus 18. Problem 65. Negative 4 times the quantity 5x plus 6, close quantity, minus 9, is an example of which term? Is it an expression, an equation, an inequality, or a function? Well, an equation has an equal sign. We know that. Equation means it has an equal sign. It does not have an equal sign, so it's not an equation. An inequality has an inequality equator. Or it could have this or this. It doesn't have any of those. So it's not an inequality. A function must have an input and an output. So for example, we could have y equals 2x plus 3. We'll see something later where we could have f of x is 4x plus 7. We must have an input and an output. We don't have an input and output. We just have an input. So it's not a function. And that leaves expression. And we know that an expression can be simplified. We look here, can't solve it because we don't have an equal sign. We can only simplify it. This is an expression. 65 is an expression.